Hey guys, so this is the additional maths series for 2016. Today I'll be doing topic 5, which is factors of polynomials, and see what they require you to do. Find factors of polynomials, solve cubic functions, and know and use the remainder and factor theorems. So let's get on. Okay, so what's a factor? Well, we'll be dealing with them, so we need to know what they are. So if I have a number, let's say 6, I divide it by some factor, let's say 2. This is our factor. It's 3. Reason it's a factor is because my remainder are equals to 0. So 2 is a factor. In this case, we're not actually dealing with numbers, we're going to be dealing with polynomials. Now, polynomials are terms such that f of x equals to x to power n, where n can be 2 for our case, 4x plus, let's say 4. Now, I will be moving on to the factor theorem. So the factor theorem states that if I divide this known polynomial by a linear factor, we know x plus 2, then our remainder is f of a. Now you need to be really careful, because this 2 is actually positive 2. So in real terms, our factor should be in the form x minus a for this theorem to work. So in this case, we could say that this is identical to x minus 2. So technically our a value here is a equals to negative 2. You'll see where I'm going in a minute. So in this case, we have our f of negative 2 equaling, let's say, negative 2 squared. And that we know that's going to be 4. Plus our 4 into minus 2, which will be minus 8. And then we have a plus 4. Overall, if we check, this is 0. This is our remainder and factor theorem. Now, which is actually true if you check here. We could factorize this to x plus 2 squared. Now if we plug in minus 2 into our x here, all this will be 0, and that's evident by what we get here. So now, getting on to, you can state that for the remainder, if we have a known function f of x and a divisor, it's called d, equal to x minus a, or in some cases 2x, let's call that a, x minus b, then our remainder is given by f of this value b over this value a. Now in some cases we could be given ax plus b. So remember, we have to use the negative value. So this could as well be equal to, if this was ax plus b, or equals to f of our negative b over a. So this will give you the remainder. Now here's where the factor theorem arises. So this is the remainder theorem. And we have our factor theorem, which states that obviously for a factor, as I showed you, r equals to 0. So use this to our advantage. You can say that this is actually f of this certain factor, let's say x minus a. In this case, our a's, if we could take it, is f of a, because our b values is 1 here. If I'd say bx minus a, so b value is 1, and this should equal to 0 if that's a factor. And usually in exams you'll be told prove that something is a factor of this function. So this is the test that you do. F of a equals to 0. If it is equal to 0, then that is a factor. Now, how do we prove that something like 2x minus 2 is a factor of f of x? The function is the same. You use the remainder theorem. You say that r must equal to 0 when you have that it should be a factor. So what would you do here? Say 2 over 2, which is f of 1, and this should have been equal to 0 if we tried it. Basically that's the idea of the factor theorem and remainder theorem. So we can prove that the factor theorem actually comes out from the remainder theorem. So this is the main Okay guys, this is all for this video. I hope it helped. Leave a comment in the comment section below. Thank you.